Hello all, welcome to Narayana IAS Academy. This is Prashant. Today we will discuss number system part 5. This is the last part of this topic number system in which we will discuss an important concept called reminders. There were several questions asked in the previous year papers. Before that, let's have a quick revision of yesterday's class. So yesterday we discussed primarily two concepts. The first one is unit digit, second one is counting number of zeros. So if you see the first one, unit digit, we discussed two model of questions. One is model 1, that is based on multiplication. For example, there is an expression 11 into 12 into 13 into 16 into 17. What is the unit digit of this expression? You just need to multiply all the unit digits of these numbers. So 1 2 is a 2, 2 3 is a 6, 6 6 is a 36. Again unit digit is 6, 6 7 is a 42. So what is the unit digit of this expression? 2. So this is the simple multiplication based models. Second, we have discussed model 2, that is primarily base to the power. So these kind of models we discussed. In this base to the power, there are again two submodels. That is, first one is if the unit digit of the base is 0, 1, 5, 6. Let it contain any power. So if the unit digit of the base is 0, 1, 5, 6, let it contain any base, your unit digit will be same. So this is the first submodel we discussed. For example, if you take any number 25 to the power 99. How to find the unit digit of this expression? What is the unit digit of the base? This is the base, this is the power. So unit digit of the base is 5. Let it contain any power. 5 square 25, 5 cube 125. So let 5 contain any power, the unit digit always will be 5 only. So unit digit of this expression will be 5. Now there is second submodel, that is if the unit digit of the base, for example it is z. Z can be of 2, 3, 4, 7, 8, 9. If the unit digit of the base is 2, 3, 4, 7, 8, 9, you have to divide the power with 4. Take the power, divide it with 4. If you get a remainder of 1, the unit digit will be z to the power 1. If the remainder is 2, unit digit will be z square. If the remainder is 3, unit digit is z cube. If the remainder is 0, what is your unit digit? Z to the power 4. For example, there is an expression 23 to the power 53. What is the unit digit of this expression? So this comes under this model. What is the base unit digit? That is 3. Whenever you have 3 as the base unit digit, take the power, divide it with 4. So 53, if you divide it with 4, 4 18s are 52, you are getting a remainder 1. If you get a remainder 1, what is your unit digit? Z to the power 1. So that is nothing but unit digit is 3 to the power 1, 3. Similarly, if you get a remainder of 3, your unit digit will be z cube. So these are the models we discussed. The first one is the multiplication. You have to multiply all the unit digits to get the ultimate unit digit. Second one is base to the power model. In that, the first one is if the unit digit of the base is 0, 1, 5, 6, always the unit digit will be same. Let it contain any power. If the unit digit of the base is z, Z can be of these values 2, 3, 4, 7, 8, 9. Then take the power, divide it with 4. If you get a remainder of 1, your unit digit will be z to the power 1. If the remainder is 2, z square. Remainder is 3, z cube. If the remainder is 0, z to the power 4. And next topic that we discussed was counting number of zeros. number of zeros. So how to find the number of zero in any expression? You have to find the number of 2 into 5 pairs. So the number of zeros will be number of 2 cross 5 pairs, right? And we have solved many questions based on this. For example, there is an expression 20 into 25 into 30 into 33 into 35. There is an expression like this. You want to find the number of zeros at the end of this product. So how to find? You have to do prime factorization into 2 into 5. 20 can be written as 5 into 4, that is nothing but 5 into 2 into 2. 25 can be written as 5 into 5. 30 is nothing but 5 into 6, so 5 into 2 into 3. What is 33? 3 into 11. What is 35? 5 sevens. So count how many number of 2's are there. Number of 2's is equals to 1, 2, 3. What are the number of 5's you have? 1, 2, 3, 4, 5. Now what is the number of 2 into 5 pairs? That is the lesser number, that is 3 only. Because you have extra 2 5's, but that doesn't matter. The combination of 2 and 5 will only give you 1 0 at the end. So there are 3 2's and 5 5's. But there are only 3 2 into 5 pairs. Now the number of zeros in this expression is 3. So these are the topics we discussed, and we have solved many questions, and also we discussed previous year's questions from these concepts. After that there was a homework question. I hope every one of you solved this one. So the question reads, the unit digit of 1, 2, 3, 4, 5k to the power 72 is 6. So the value of k, options are 6, 8, 2 and all of these. Whenever there is an option all of these, we have to be careful. So what can be the value of k? So the expression is 1, 2, 3, 4, 5 k to the power 72. So when we discussed base to the power model, if the unit digit of the base is 0, 1, 5, 6, let it contain any power, your unit digit will be same. So k can be 6, right? If there is 6, let it contain any power, the unit digit will always be 6. Unit digit will be 6. So one of the values that k can take is 6. But there is an option all of these. So we have to be careful. Let's go through the options. If you take 2, so 2 to the power 72. Find what is the unit digit. This is nothing but the second submodel of the base to the power. If the unit digit is, base unit digit is 2, 3, 4, 7, 8, 9. What we have to do? Take the power, divide it with 4. If the remainder is 1, unit digit is z to the power 1, 2 z square, 3 z cube, 0 z to the power 4. Now 72 is the power. Divide 4 18s are 72, 0. Now what is the unit digit? 2 to the power 4. That is nothing but 16. Again you are getting 6 as unit digit. Right? So k's value can be 2 also. 6 and 2, A and C. Now if you check for 8 also, 8 to the power 72. What is the unit digit? Take the power, divide it with 4, you are getting a remainder of 0. Then the unit digit is z to the power 4, that is 8 to the power 4. So 8 into 8 into 8 into 8. 8 8 is 64, unit digit is 4. 8 8 is 64, unit digit is 4. 4 into 4 16, unit digit is 6. So even for 8 you are getting a unit digit of 6 only. So the value of k can be 6, 8, 2. So answer is all of these. So this was the homework question given yesterday. Try to solve all the homework question. So our today's concept is reminders. Very important one. So what is a remainder? It is the value left over after the process of division. For example, if you take 9, divide it with 2, 2 fours are 8, you are getting a value that is left over 1. So this is called remainder, right? And in the division process, we know what is this 4? This is quotient. What is this 2? Divisor. What is this 9? Dividend, right? We all knew this and we discussed it in the HCM and LCF concept also. Remainder is nothing but it is the value left over after the process of division. For example, if you take 53 and divide it with 4, 4 18s are 52, you are getting a value of 1. This one is called remainder, right? Very simple one. For example, if you take any value like 60, if you divide it with 12, 12 5 is a 60, you are getting 0 as the remainder. If you are getting 0 remainder, that means that number is exactly divisible, or that number is perfectly divisible by this divisor. If you are not getting non-zero remainder, for example, if you are getting 1 or any other remainder, that means that number is not perfectly divisible by that particular divisor. So this is very simple concept, remainders. Next, the concept of negative remainder. What is this negative remainder? For example, there is a number 49. Divide it with 5. So what is the remainder? 5 nines are 45. You are getting 4 as the remainder. Now, if you go one step ahead, if you divide the same 49 with 10, 5 tens are 50. You are getting minus 1 as the remainder. In the actual sense, minus 1 is not the actual remainder. What is the actual remainder? 4. But why we are finding this negative remainder is to make our calculation simpler. I will show you how to use this negative remainder while solving problems. So if you are getting minus 1 as the remainder, to get the original remainder, take the divisor and put minus 1. That is nothing but 5 minus 1 is 4. This is the concept of negative remainder. For example, there is a number 12. If you divide uh, if you divide 31 with 12, no, just a minute, 37. If you divide 37 with 12, what is the remainder? You can put 12 to the 24, you are getting 13 as the remainder. If you go one step ahead, that is nothing but, sorry, just a minute. There is 35. Divide 35 with 12. That is nothing but 12 to the 24. You are getting a remainder of 11. If you go one step ahead, 12 3s are 36. You are getting a remainder of minus 1. If you want to get the actual remainder, take the divisor and do minus 1. You are getting the same again. But the kind of calculation that you are doing here is comparatively simple. I will show you how to use this negative remainder while solving problems also. Now, there are three important rules in the concept of remainder. For example, there is an expression called (11 into 12 into 14 into 39). If you divide it with 7, what is the remainder? Suppose there is an example, there is an expression 2 to the power 99. If you divide it with 8, what is the remainder? So for these kind of questions, the calculation will be very difficult. For that, we will follow three rules. The first one is simplification rule. The second one is Fermat's theorem. The third one is cyclicity theorem. First, let's discuss this simplification rule through an example. If suppose there is a 12 into 13 divided with 11. Normally, how to find the remainder? 12 into 13 is nothing but 156 divided with 12. 11 ones are 11, 46, 11 fours are 44. You are getting a remainder of 2. But this is little difficult process and time consuming. Now, how to apply this simplification rule? 12 into 13 divided by 11. Take first this one. If you divide 12 with 11, what is the remainder? 1. 11 ones are 11, remainder is 1. Next, do this division. Take 13 divided with 11, what is the remainder? 2. So, 1 into 2 is your remainder. Understood? Next, I will show you another example. "12 into 16 divided by 15. Normally, how to find the remainder? Take the multiplication of 12 into 16 divided with 15, you will get the remainder. But that is very time consuming process. Now, how to apply this simplification rule? Take 12 by 15. What is 12 by 15? What is the remainder? 12 is less than 15, so 15 zeros are 0. So the remainder is 12. What is the remainder if you divide 16 with 15? 15 ones are 15, the remainder is 1. So what is your remainder? In this case, the remainder is 12. In this case is 1. So multiply 12 ones are 12 is your remainder. Okay. Now, if you apply the negative remainder concept, it will become more easy. How? Take 12 into 16 divided by 15. If you take the division of 12 and 15, here you have applied 15 zeros are 0, 12 is the remainder. If you take 15 ones are 15, the remainder is minus 3, right? Minus 3. What is the remainder in this case? 1. If you multiply minus 3 and 1, you are getting minus 3 as your remainder. But this is not the actual remainder. This is just to make our calculation simpler. Now what is the original remainder? Take this divisor, minus 3, 12 is your remainder. Understood? So what is the simplification rule? You have to take the individual division process. In that you are getting individual remainders. Multiply those remainders, you will get the final remainder. To make the calculations further simple, you can apply the concept of negative remainder. So you are getting the negative remainder of minus 3, here plus 1, multiplication is minus 3. Whenever you are getting a value of minus 3, you have to take it out from the divisor. So 15 minus 3, 12. So you are getting the same remainder in both the cases. Now there is one more addition to this simplification rule. If you take the same thing again, 12 into 16 divided by 15. Now this is the third addition. The first one we have done, you have to take out individual remainders and multiply it, you will get the ultimate remainder. What is the second addition we have added to make the calculation simpler? That is nothing but negative remainder. Now the third addition is to make it much more simpler. 12 into 13. 12 and 15 are divided by 3, right? 3 fours are, 3 fives are. So you are multiplying both the numerator and denominator, numerator and denominator with 3. So write these 3 separately. Now there is 4 into 16 by 5. Now do the simplification process. What is the remainder? 4 5s are minus 1. And what is the remainder? 5 3s are 15, 1. Right? You are getting minus 1 as the remainder. But here you have taken 1. You have divided both the numerator and denominator with 3, right? So multiply this with here. 3 into minus 1, you are getting minus 3. But remainder cannot be negative. To get the original remainder, what is the original divisor? That is 15 minus 3 is 12. Understood? So if we summarize all the simplification rules with the same example, 12 into 15 by 16. What is the first process to find the remainder? Take the product of 12 into 15 divided with 16, you will get the remainder. But this is very time consuming process. How to apply the simplification rule? The first one, 12 into 15 divided by 16. Take the individual divisions. So, same example, 12 into 16 by 12 into 16 by 15. So what is the original process? 12 into 16 divided with 15, you will get the remainder, but this is time consuming process. What is the first simplification we can do? Take the individual divisions. So what is the remainder of this 12 by 15? 12 is the remainder, 15 zeros are. Next, 16 by 15, what is the remainder? 15 ones are 15, 1 is your remainder. So your remainder will be 12 into 1, that is 12. To make it more simple, you have to use the negative remainder concept. That is nothing but 12 into 16 by 15. 12 by 15, what is the negative remainder? Minus 3. Here what is the remainder? 1. So your remainder is minus 3 into 1, that is minus 3. But whenever you get minus negative remainder, take it from the divisor. So that is 12. In this case also you are getting the same remainder. To make this calculation more simpler, you have to apply this one. 12 into 16 by 15. 3 4s are 3 5s are. So take this 3 out, write it separately. Now what is the expression? 4 into 16 by 5. If you divide 4 with 5, you are getting negative remainder minus 1. 5 3s are 15, you are getting 1 as the remainder. So for this case, minus 1 into 1, that is nothing but minus 1 is your remainder. And you have put 3 separately, multiply with it. 3 into minus 1 is minus 3. But what is the original remainder? Take it from the divisor, that is 12. Understood? This is the simplification rule. Applying the simplification rule, try to solve this problem. Find the remainder of the expression 19 into 20 into 21 divided by 9. If you apply the simplification rule, it is very easy. 19 into 20 into 21 divided by 9. So 19 by 9, what is the remainder? 9 2s are 18, 1 is the remainder. For 20, 2. For 21, 3. So the remainder is 1 into 2 into 3. That is nothing but 6. Option D. Try to solve this one. Find the remainder of the expression 12 into 19 into 28 divided by 15. Apply all the simplification rules. The first one, individual division, the concept of negative remainder, and also dividing the same numerator with another divisor, denominator and numerator with any other divisor. So if you take the expression 12 into 19 into 28 by 15, for 12 and 15 there is a common factor, right? That is nothing but 3 4s are 3 5s are. So write this 3 separately. What is the remaining expression? 4 into 19 into 28 by 5. If you divide this 4 with 5, what is the remainder? Remainder can be 4 also, The remainder can be minus 1 also. 5 ones are 5 minus 1. So to make it more simple, you can use this negative remainder. And what is the remainder for 19 by 5? 5 fours are 20. 19 minus 20 minus 1 is the remainder. And what about this one? 5 6 are 30. 28. So minus 2. So what is your remainder in this case? Minus 1 into minus 1 into minus 2. So minus minus minus, it will give you minus and 2. Now you have put these 3 separately, multiply these two. 3 into minus 2 is nothing but minus 6. Remainder cannot be negative. To get the original remainder, take it out from the original divisor. So what is the original divisor? 15 minus 6 is nothing but 7 is your remainder. Option B. So what we have done here, take out if any common factor is there, write it separately, and for the remaining expression you can use the negative remainders. You got the negative remainder of minus 2, so multiply these two, minus 6, take it from the original divisor, you are getting 7 as the remainder. Now the question is little more difficult. Find the remainder of the expression 1001, 1002, 1003 into 1004 divided by 15. Find the remainder using all the simplification rules that we learned. Finding remainder for these expressions is very easy if you apply all the simplification rules. So let's try to solve this one. So what is the expression given? 1001, 1002, 1003 into 1004 divided by 15. Try to find if there is any common factor or not. 15 can be divisible by 3. Here you have to apply the divisibility rules that we learned earlier. So check whether any numerator is divisible by 3 or not. What is the divisibility rule for 3? Sum of all the digits should be divisible by 3. So 1 plus 1 2, it's not divisible. 1 plus 2 3, it is divisible. So 3 5s are, and 3 3s are, 3 3s are, 3 4s are, right? So there is one common factor for this numerator and denominator. So take it out separately. 3. Now what is the remaining expression? 1001, 334, 1003 and 1004 divided by 5. Right? Now this 1001 and 5. What is the remainder? Here also you can apply the divisibility rule. What is the divisibility rule for 5? Either the unit digit should be 0 or unit digit should be 5. So 1001, that means 100 is divisible by 5. So we will get the remainder of 1. Similarly for 334, 335 is divisible. So you are getting a remainder of minus 1. Here also 1003, 1005 is divisible by 5. So that means you will get the remainder of minus 2. Similarly in this case also 1005 is divisible. So the remainder is minus 1. So what are the remainders? 1 into minus 1 into minus 2 into minus 1. That is nothing but 3 times minus symbol is there. So minus 2. Now there is a factor you separated. Multiply these two. 3 into minus 2 is nothing but minus 6. Right? The remainder cannot be negative. To get the original remainder, what is the original divisor? 15 minus 6, 7. 1 minute. So in this case 1001 is one remainder, and 334 minus 1 minus 2, here also minus 1, this is nothing but 2 minus 2, the remainder is 3. 3 into minus 2 is minus 6. 15 minus 6 is 9. So the answer is 9. Understood? This is how we should apply the simplification rules. Take out any common factor, then apply the simplification rules of negative remainder and the individual division. You are getting -2. So multiply these two, 3 minus 2, that is 6 minus 6. The remainder cannot be negative. So take out from the original divisor, 15 minus 6 is 9. That is your answer. In the similar way, try to solve this one. Find the remainder of the expression 12374851 into 7273 divided by 12. Apply the simplification rule, you will get the answer. Okay, let's solve this one. So what is the given expression? 1237 into 4851, 7273 divided by 12. What is the first simplification rule you have to apply? Check whether there is any common factor for the numerator and denominator. So 12 is divisible by 2, but all are odd numbers, so it is not divisible. So 12 is divisible by 3, right? So 3 4s are, check any number if it is divisible by. If you take 4851, take sum of all the digits. 4 plus 8 12, 12 plus 5 17 plus 1 18. So if sum of all the digits is divisible by 3, the number is divisible by 3. So 3 ones are, 3 6s are, 3 ones are, and 3 7s are, right? So what is that common factor? Write it out separately. What is the remaining expression? 1237 into 1617 into 7273 divided by 4. Now the expression is simplified. What is the remainder if you divide 1237 with 4? Again you have to apply the divisibility rules. So this is how you should apply. What is the divisibility rule for 4? Last two digits should be divisible by 4. What is the last two digits? 37. 4 nines are 36, but there is 37, so the remainder is 1. Similarly, if you see what is the last two digits, 17. 4 4 is 16, 1 is your remainder. Similarly, 7273, 4 18s are 72, so the remainder is 1. So for this expression, what is the remainder? 1 into 1 into 1, that is 1. Here you have separated 3, so 3 into 1, 3 is your remainder. You are getting positive remainder, that is 3, which is also less than 12, so the answer is 3. If you are getting any negative remainder, you have to take it out from the divisor. If you are getting positive remainder, that is your answer. Now try to solve this one. Find the remainder of the expression 2 to the power 76 divided by 96. Don't be confused by seeing the expression 2 to the power 76. It can also be solved using this simplification rule. Okay, let's solve this one. So what is the given expression? 2 to the power 76 by 96. What is 2 to the power 76? That is, we are multiplying 2 76 times. Now, what is the first step in the simplification process? Find the common factors between the numerator and denominator. So 96 is also divisible by 2, right? So let's take out 96 and break it into 2's. So that is 248's, 224's, 212, 2 6 are 12, 2 3's are, right? So 96 can be written as, there are 5 2's, 2 to the power 5 into 3. Now the same 2 to the power 76 can be written as 2 to the power 5 into 2 to the power 71, right? 71 plus 5 is 76. So I am writing 2 to the power 76 in terms of 2 to the power 5 into 2 to the power 71. Now 96 can be written as 2 to the power 5 and 3. Now there is one common factor for the numerator and denominator. So remove it and write it separately, 2 to the power 5. Now what is the remaining expression? 2 to the power 71 into 3. That is nothing but you are writing 2 71 times. You are multiplying 2 71 times. So 2 into so on 71 times by 3. Now do this individual simplification, individual division. If you divide 2 with 3, what is your remainder? -1, negative remainder. So for this also -1 up to 71 times. So if you multiply -1 71 times, you will get again -1 because that is an odd number of multiplication. So for this expression, the remainder is -1. You have already separated 2 to the power 5. So divide these two. 2 to the power 5 into -1 is nothing but, what is 2 to the power 5? 32. 32 into -1 is -32. What is the original remainder? If you are getting negative remainder, take it out from the original divisor. What is the original divisor? 96. So 96 minus 32 is nothing but 64 is your remainder. Option C. So there is nothing to panic after seeing this expression 2 to the power 76 by 96. It also can be solved using the simplification rule. First, try to take out if there is any common factor for the numerator and the denominator. So I have break down the 96 like this, 2 to the power into 3, and you can write 2 to the power 76 in terms of 2 to the power 71 into 2 to the power 5. So take this 2 to the power 5, that is nothing but 32. Now what is the remaining expression? Find the remainder. You are getting -1. Multiply this 2 to the power 5 with -1, that is -32. So take it out from the original divisor, 64 you are getting as the answer. Understood? Now in the similar way, try to find this remainder. Find the remainder of the expression 5 to the power 500 divided by 500. Okay, let's solve this one. So what is the given expression? 5 to the power 500 divided by 500. Similarly, you have to find if there is any common factor for the numerator and denominator. So try to break this 500 in terms of 5. So 5 hundreds are 500, 5 20s are, and 5 4s are, right? Now if you see, this 500 can be written as 5 cube into 4. Now this 5 to the power 500 can also be written as 5 cube into 5 to the power 497, right? Divided by, what is 500? 5 cube into 4. Now you can take this out, write it separately, 5 cube. Now what is the remaining expression? 5 to the power 497 divided by 4. 5 to the power 497 is nothing but you are multiplying 5 497 times. So if you divide 5 with 4, what is the remainder? 1. So in all the cases, 1 into 1 into 1 up to 497 times. So for this expression, what is the remainder? 1 multiplied with 1, that is 1 is your remainder. And you have taken this 5 cube separately. So multiply these two. 5 cube is nothing but 125 into 1. That is your remainder. Understood? Here you are getting a positive remainder, so that is your remainder. If you are getting a negative remainder, take it out from the original divisor. So the answer is option A, 125. Now try to solve this question. This was asked in CSAT 2023, very recent paper. What is the remainder when 85 into 87 into 89 into 91 into 95 into 96 is divided by 100? Okay, let's solve this one. So what is the given expression? 85 into 87 into 89 into 91, 95 into 96 divided by 100. Try to find any common factors are there. 100 can be divided with 5. So 5 20s are, 5 17s are. Again 5 4s are, 5 19s are. 96 can be divided right with 4, right? 4 2s are and 4 4s are. If you see, the entire expression is perfectly divisible by this number. If it is perfectly divisible, what is your remainder? 0. Simple. Answer is option A. So whatever the given expression, it is perfectly divisible by 100. So the remainder is 0. Solve the next one. So this was also asked in CSAT 2022 paper. What is the remainder when 91 into 92, 93, 94 up to 99 is divided by 1261? Okay, let's solve this one. What is the given expression? 91, 92, 93, 94, 95, 96, 7, 8, 9 divided by 1261. Always check whether there is any common factor between the numerators and denominators. So if you check 1261, it is not divisible by 2, 3, 1 plus 2, 3, 3 plus 6, 9 plus 1, it is not divisible by 3, not divisible by 4, 5, 6, 7, 8, 10 is also not divisible, 12 is also not divisible, 13, if you take by 13, this is nothing but 13 nines are and 91 sevens are. So 12 16 is divisible by 13, 13 19 sevens are. So 13 sevens are 91. You got one common factor, that is 13. And if you see 97 and 97, we can cancel, right? So the entire expression is perfectly divisible by the given number 1261. If it is perfectly divisible, what is the remainder? 0. That is your answer. So 2022 and 23, they have asked similar question with the remainder 0 as the answer. See the next question. This was also asked in 2020 paper. Similar model questions from the same concept being asked again and again. What is the remainder when 51 into 27 into 35 into 62 into 75 is divided by 100? Apply the simplification rule. And this is very easy questions. These are 51 into 27 into 35, 62 into 75. It is divided by 100. So what is the first step to do? Check any common factor. So this is divided by 25, right? 25 4s are, 25 3s are. So take the 25 out, write it separately. What is the remaining expression? 51 into 27 into 35 into 62 into 3 divided by 4. Now find the individual remainders. If you divide 51 with 4, 4 18s are 52, minus 1, negative remainder. Similarly, 27, 4 sevens are 28, minus 1 is your remainder. 35, 4 nines are 36, minus 1 is your remainder. What about 62? 4 15s are 60, 2 is your remainder. And what about 3? 4 ones are 4, minus 1 is your remainder. Now for this expression, what is the remainder? Minus 1 into minus 1 into minus 1 into minus 1 into minus 2 into minus 1. So how many times minus is there? 1, 2, 3, 4. So it will give you plus. Next 2 into 1, that is 2. For this expression you are getting 2 as the remainder. Already you have separated 2 to the power 5, that is nothing but 32. So multiply these two. 32 into 2, that is 64. Sorry, this is 25. Sorry, not 2 to the power 5, 25. So multiply these two. 25 into 2, that is 50 is your remainder. Very simple, option A. So write the given expression, take out any common factor. 25 4s are 100, 25 3s are 75. Write that 25 separately. Now what is the remaining expression? Apply the negative remainder concept and individual division also. So you are getting 2 as the remainder for this expression. The separated 25 into 2 is 50. That is your remainder. Next question. This was also asked in 2023 paper. How many questions are being asked in the exam? Understood how much important this topic is. Reminders. What is the remainder if 2 to the power 192 is divided by 6? Very simple one. Just apply the simplification rules. Okay, let's solve this one. What is the given expression? 2 to the power 192 divided by 6. What is the first step you have to do? Check whether any common factor is there or not. There is 2 192 times 6 is also divisible by 2, so take out 2 first. 2 to the power 192 divided by 2 into 3, so this can also be written as, this is nothing but 2 into 2 to the power 191 divided by 2 into 3. 2 is common in both numerator and denominator, take it out. Write these two separately. What is the remaining expression? 2 to the power 191 by 3. So this is nothing but 2 into up to 191 times by 3. If you divide 2 with 3, what is the remainder? Minus 1. So in every case minus 1 and all. How many times minus 1 is there? 191 times, odd number. So your remainder is minus 1. You have already separated 2, so multiply these two. 2 into minus 1 is minus 2. If you are getting a negative remainder, to get the original remainder, take it from the original divisor. What is the divisor? 6 minus 2 is 4. That is your answer. Option D. So using the simplification rules, many questions can be solved from the remainder concept. So this is the simplification rule. Next we will discuss Fermat's theorem. So what is this Fermat's theorem? If there is any number which is in the form of a to the power p minus 1 by p, okay, if there is any number in this form, p here is a prime number, and also one more condition, a and p should be co-primes. What are co-primes? They should have 1 as the only common factor. That is nothing but their HCF is 1. So what are the conditions? The form is a to the power p minus 1 divided by p. P should be a prime number. A and P should be co-primes. So that means HCF of A and P is 1. In this case, always the remainder will be 1. So what is for Fermat's theorem? If there is any number in this form, a to the power p minus 1 divided by p, and they should fulfill two conditions. P should be a prime number and both A and B should be co-primes. Co-primes means their HCF should be 1. In that case, always the remainder will be 1. For example, if you take, if there is an expression 2 to the power 4 divided by 5. This is nothing but 2 to the power 5 minus 1 by 5, right? Check all the conditions. P is a prime number. What is P? 5. What is A? 2. P is a prime number. The condition is satisfying. What is A? 2. 2 and 5. There are no common factors for 2 and 5 except 1. So 2 and 5 are co-primes. Now what is the remainder for this case? Always 1. If you want to check, you can check. 2 to the power 4 is 16. 5 3 is a 15. You are getting a remainder of 1. For example, if you take 5 to the power 16 divided by 17, it can be written as 5 to the power 17 minus 1 by 17, right? What is P here? 17. 17 is a prime number. Condition is satisfying. And A and P, what is A? 5. 5 and 17 should be co-primes. Both are prime numbers. So the only common factor is 1. So they are co-primes. Condition is satisfying. So for this expression 5 to the power 16 divided by 17, what is the remainder? 1. So this is the Fermat's theorem. Now try to apply this Fermat's theorem and find the solution for this problem. Find the remainder of the expression 2 to the power 89 by 89. You have to apply that rule. No need to be confused. You may see that power is 89, the denominator is also 89, but you can still apply Fermat's theorem here. Okay, let's solve this one. What is the given expression? 2 to the power 89, 88, 89. What is the Fermat's theorem expression? A to the power p minus 1 by p. So that means power should be one number less than the denominator. So there has to be 88 here. So how can we write 2 to the power 89? 2 into 2 to the power 88 by 89. 89 is a prime number. 88 is nothing but 89 minus 1. Now we can apply a to the power p minus 1 by p. Fermat's theorem. Now in this there are two individual divisions. 2 by 89. What is the remainder? 2. 89 zeros are 0. 2 is the remainder. And for this expression, what is the remainder? It is nothing but in the form of this Fermat's expression. Remainder is 1. So 2 into 1 is 2. That is your remainder. Simple, right? Even if the power and denominator are not same, you can convert it. You have to write it in the form of 2 to the power 88 by 89. 1, 2 is separated. So 2 into, for this expression, remainder is 1. Answer is 2. Try to solve this one. Find the remainder of the expression 3 to the power 94 divided by 47. Try to break down the expression into Fermat's expression. You will get the answer. Okay, let's solve this one. The expression is 3 to the power 94 by 47. 47 is a prime number, so we can apply Fermat's theorem. We can try to apply Fermat's expression here. So if this is 47, there has to be 46 in the numerator, in the power. So how can we break down? 94 can be written as 46 plus 46, 46, 46, 92 plus 2, right? So 3 to the power 94 is nothing but 3 to the power 46 into 3 to the power 46 into 2, 3 square, right? 3 square divided by 47. Now this expression is nothing but a to the power p minus 1 by p, right? P is a prime number, 47 is a prime number, 3 and 47 both are prime numbers, so the common factor is only 1, so they are co-primes. So for this expression, what is the remainder? 1. And if you take 3 to the power 46 by 47, for this expression the remainder is 1. And what about this one? 3 square is 9. 9 by 47, the remainder is 9. So the total remainder is 9. Understood? Option D is the answer. Similar question, try to solve this one. Find the remainder of the expression 5 to the power 91 divided by 31. 31 is a prime number, so you can try solving this question using Fermat's theorem. So break down the expression, try to get 31, 30 like that. Answer will come. Okay, let's solve this one. So what is the given expression? 5 to the power 91 divided by 31. 31 is a prime number, so we can try to solve this using Fermat's theorem. But it has to be 30 in the numerator. So 91 can be written as 30 plus 30 plus 30 plus 1. So that means 5 to the power 30 into 5 to the power 30 into 5 to the power 30 into 5 to the power 1 divided by 31. Now this is in the form of a to the power p minus 1 by p. P is 31 prime number, 5 and 31 are co-primes. So what is the remainder for this expression? 1. Similarly for this one, 1. Similarly for this one, 1 is the remainder. Now what is the remainder for 5 by 31? 5 is the remainder. Now the total remainder is 5. Understood? Option A is the answer. So this is how we solve questions using Fermat's theorem. What is this Fermat's theorem? If there is an expression in the form of a to the power p minus 1 by p, the two conditions are p should be a prime number and a and p, they should be co-primes. So that means their HCF or the only common factor should be 1. So in that case, if these two conditions are fulfilling, the remainder of the expression is always 1. And this is how we can solve these kind of questions. Always try to convert it in the form of Fermat's expression. You will get the answer. Now the third rule is cyclicity theorem. What is this cyclicity theorem? Let's understand it through an example. For example, there is an expression 2 to the power 49 divided by 7. How to get the remainder of this expression? We can solve it using the simplification rule also. We can solve it using the Fermat's theorem also. But sometimes there will be some expressions which cannot be solved by Fermat's theorem. Then we can apply this cyclicity theorem. So how to apply the cyclicity theorem? There are procedures you have to follow. The first step is check whether the base is less than the denominator. So this is the first step we have to do. What is the base? Here the base is 2. This is the base. This is the denominator. Check whether 2 is less than 7 or not. Yes, 2 is less than 7. If not, for example, there is an expression called 9 to the power 49 by 7. Here the base is 9, denominator is 7. 9 is greater than 7. Then what you have to do is divide that 9 with 7. You are getting remainder as 2. Now you can substitute 2 in the case of 9. So you can take the expression 2 to the power 49 by 7 itself. Understood? If there is an expression 10 to the power 49 by 7. So what is the first step we have to do? Check whether the base is less than 7 or not. If it is less than, you can proceed for the next step. If it is greater than, take the 10 divided with the denominator. You are getting remainder as 3. Now substitute 3 in the case of 10. We don't need 10 at all. So you can consider the expression 3 to the power 49 by 7. You can proceed to the next step. So this is the first step. Next step. Write the given expression in the form of 2 to the power n by 7. What is n here? That is 49. Now we have to check the cyclicity. Now we have to check the cyclicity. What is the cyclicity means? You have to substitute values to the n like 1, 2, 3, 4, 7 and all. For example, if you substitute 1, 2 to the power 1 by 7, what is the remainder? 2 to the power 1 by 7, 2 is the remainder. If you put 2 for the n, 2 to the 2 square by 7, the remainder is 4. If you put 2 cube by 7, the remainder is 2 cube is 8, remainder is 1. If you put 2 to the power 4 by 7, 16 by 7, so the remainder is 2. So you have to continue the process till you get the same remainder or negative remainder minus 1. So there are two cases. You have to repeat the process till you get the same remainder or minus 1 remainder. Now if you get the same remainder, count the number of previous steps. Number of previous steps. That will be your cyclicity. So here you are getting same remainder. What are the number of previous steps? You have to leave this step 1, 2, 3. So 3 is your cyclicity. If you get the negative remainder minus 1, the cyclicity is total number of steps into 2. For example, if you are getting minus 1 here, stop the process. What are the total number of steps? You have to include this step also. 1, 2, 3, 4. 4 into 2. 8 is your cyclicity. Understood? So what is the first step? We have to check whether the base is less than the denominator or not. If it is okay, move to the next step. If it is not less than the denominator, take the remainder. You can substitute that remainder with that base. What is the next step? We have to find the cyclicity. For that, you can assume 2 to the power n by 7. N is 49. So you have to substitute values for n. 2 to the power 1, 2 square, 2 cube, 2, 7. Divided with 7. You will get all the remainders. And you have to stop till first condition is you have to get the same remainder. Second condition is you have to get the remainder minus 1. If you are getting the same remainder, you have to count the previous number of steps. So you have to leave that same remainder step. How many previous number of steps are there? 1, 2, 3. 3 is your cyclicity. That is, if you get the same remainder. If suppose you are getting -1 as a remainder, you have to count that step also. That is total number of steps 1, 2, 3, 4. You have to multiply it with 2. Then 8 is your cyclicity. Now you found the cyclicity. Next, what we have to do? So, 2 to the power 49 by 7. We have done the first step. Base is less than the denominator. Second one, 2 to the power n by 7. N is nothing but 49. We have found the cyclicity. Cyclicity is nothing but 3 we got here. Now divide this n with this cyclicity. What is the cyclicity? 3. What is this n? 49. If you do it, 3 ones are 3, 1 9, 3 6 are 18, 1 is your remainder. Now you can substitute this remainder with the n. So what is 2 to the power n by 7? 2 to the power 49 by 7. In the place of n, you can use this remainder. So that is nothing but 2 to the power 1 by 7. Now the entire expression can be simplified to 2 to the power 1 by 7. Now what is the remainder for this case? That is 2. Your answer is 2. Understood? Let's understand this through another example. Then you will get a clear idea. So the example, 3 to the power 97 by 28. 3 to the power 97 by 28. So this is the expression. What is the first step? Base should be less than denominator. Here, what is the base? 3 is the base and 28 is the denominator. 3 is less than 28. Okay. So the condition is satisfied. You can move to the next step. What is the second step? You have to find the cyclicity. How to find the cyclicity? You can write it in 3 to the power n by 28 form. What is the n? 97. How to find the cyclicity? Put some values to the n. So 3 to the power 1 by 28. For all these cases, what are the remainders? 3 to the power 1 by 28. 3 is the remainder. 3 square by 28. You are putting value of 2 for the n. 9 is the remainder. 3 cube by 28. What is the remainder? 27 or minus 1 also. What is 3 cube? 27. 28. 28 ones are 28. Remainder is minus 1. Now as I told you, when you get the minus 1 as the remainder, you have to count the total number of steps. That is 1, 2, 3 and multiply with 2. 6 is your cyclicity. So when you get the same remainder, you have to count the number of previous steps. You have to leave that particular same remainder step, count the number of previous steps. If you are getting the remainder of minus 1, count the total number of steps, multiply it with 2. So 1, 2, 3, 3 steps into 2. So 6 is your cyclicity. So we got 6 as cyclicity. Now divide the n with this cyclicity. So 97 divided by 6. 6 ones are 6, 37, 6 6 are 36, remainder is 1. Now you can put this remainder in the place of n. So what is 3 to the power n by 28? You can put 1 in the place of n. 3 to the power 1 by 28. That means the whole expression can be simplified into this expression. So 3 by 28, what is the remainder? 3. So that is your answer. So this is how you should apply cyclicity theorem. There will be some expressions which can be solved using simplification rule or otherwise Fermat's theorem. But there are some expressions where you cannot apply the Fermat's theorem and all. If you see 28, it is not a prime number. So in these kind of cases, you have to apply cyclicity theorem. If you summarize, first you have to check base should be less than the denominator. If it is greater than, take the remainder, substitute that base with the remainder, it is completely fine. Second step is you have to find the cyclicity. 3 to the power n can be 97. Put the values for n 1, 2, 3, 4 and all. You have to repeat the process till you get same remainder or minus 1 as the remainder. If you get same remainder, count the number of previous steps. If you get the remainder as minus 1, total number of steps multiplied with 2 is your cyclicity. After that, with this cyclicity, divide the 97, that is the power n. You will get one remainder. Now it is completely fine to substitute that n with this remainder. Now for this expression, find the remainder. 3 to the power 1 by 28, remainder is 3, so the answer is 3. So that is remainder of this expression is 3. Understood? Now using the cyclicity theorem, try to solve this question. Find the remainder of the expression 51 to the power 203 divided by 7. You can pause the video and solve this one. Okay, let me solve it. So what is the given expression? 51 to the power 203 by 7. So what is the first step? Base should be less than denominator. What is the base here? 51 is the base, 7 is the denominator. But 51 is greater than the denominator. Then what you have to do? Divide that base with this denominator. 7 sevens are 49. 2 is the remainder. It is completely fine to substitute this base with this denominator. So that nothing but 51 can be replaced with 2 to the power 203 by 7. So this is your simplified expression. If you find remainder for this expression, that will be your remainder. Now what is the second step? We have to find the cyclicity. So what is the cyclicity for this one? So that is 2 to the power 203 by 7 can be written like 2 to the power n by 7. Now if you see 2 to the power 1 by 7, what is the remainder? 2. 2 square by 7, that is 4. 2 to the power 8 by 7, remainder is 1. 2 to the power 2 cube by 7, 2 to the power 4 by 7, remainder is 2. Now the remainder is repeated. You have to count when the remainder is repeated. You have to count only previous steps 1, 2, 3. So cyclicity is 3. Now divide this n, that is nothing but 203 with this cyclicity 203. So 3 6 are 18, 23, that is nothing but 3 7s are 21. You are getting 2. Now substitute that n with this 2 remainder. So what is this third step? 2 to the power remainder 2 by 7. This is nothing but 4 by 7. What is the remainder? 4. So that is your answer. Understood? Option B. There are 3 important steps. First, you have to check base is less than the denominator or not. If it is greater than, divide that base with the denominator, consider the remainder. Now the expression can be simplified by substituting that base with this remainder. So 2 to the power 203 by 7. Next you have to find the cyclicity. You have to check all the cases. If same remainder, count the previous number of steps. If you are getting minus 1 as the remainder, you have to take total number of steps 4 into 2, 8. After that, divide that n with this cyclicity, you will get one remainder. Now substitute that n with this remainder. So 2 square by 7. What is the remainder for this expression? 4. So 4 is the answer. Now, so this question was asked in CSAT 2021 paper. If 3 to the power 2019 is divided by 10, then what is the remainder? So if you see these kind of questions, you can understand 10 is not a prime number. So it is little difficult to apply the Fermat's theorem. Then you have to apply the cyclicity theorem. So try to solve this one using cyclicity theorem. So if you apply the cyclicity theorem, this is very simple to solve. So what is the given expression? 3 to the power 2019 divided by 10. So what is the first step? Base should be less than denominator, right? So what is the base? 3 is the base. What is the denominator? 10. 3 is less than 10, so you can move to the next step. That is, it can be written like 3 to the power n by 10. The n is nothing but 2019. You have to find the cyclicity of this expression. How to find 3 to the power 1 by 10? What is the remainder? 3. If you put value 2 for the n, 3 square by 10, that is 9 by 10. What is the remainder? Minus 1. Now what is the cyclicity if you get minus 1 as the remainder? Count the total number of steps, multiply it with 2. Total number of steps are 1 and 2. So 2 into 2 is 4. So cyclicity is 4. Now you got the cyclicity is 4. Now divide that n. What is n 2019 with the cyclicity 4? So 4 5s are 20, 0 19, and 4 4s are 16, 3 is the remainder. Now this n can be substituted with remainder 3. So that is nothing but 3 by 10. So what is the remainder? 27 by 10. 7 is the remainder. So option C. So this is how you should use the cyclicity theorem. Check the base whether it is less than the denominator or not. If it is not, consider the remainder. If it is yes, move to the next step. Next you have to find the cyclicity. Here we are getting minus 1 as the remainder. If you are getting the same remainder, consider the previous number of steps. If you are getting minus 1 as the remainder, total number of steps multiplied by 2. So that is nothing but 4 is your cyclicity. After that, divide that n with this cyclicity, you will get one remainder. N can be replaced with that remainder. So 3 cube by 10, 27 by 10. 10 2s are 20, remainder is 7. So 7 is your answer C. Now the last concept, that is greatest and smallest numbers. So let's understand these concept using examples. So the question is like, the greatest 4-digit number exactly divisible by each of 12, 15, 18, 27. And if you remember, in the concept of LCM and HCF, we have discussed these kind of problems. But the only difference is they are asking what is the greatest 4-digit number, what is the smallest 3-digit number. So like that the questions will be asked. So normally if you see what is the greatest 4-digit number, that is nothing but 9999, highest 4-digit number. What is the smallest 4-digit number? That is 100, like this, right? So what is the highest 3-digit number? 999. What is the smallest 3-digit number? 100. This all we knew, right? Now whenever question is like this, what is the greatest 4-digit number? That is divisible by each of this one. So divisible by each of these numbers. So then you have to find the LCM first. So what is the LCM of all these divisors? So that is 12, 15, 18, 27. So if you do it with 3, 3 4s are 3 5s are 3 6s are 3 9s are. If you put 2, 2 3s are 2 5s are 2 3s are 9s are. 3 1s are 3 5s are 3 1s are 3 3s are. Okay. So 5 3s are 15, 15 3s are 45, 45 2s are 90, 93s are 270. So the LCM is 270. So first find the LCM of all the given devices. Next, what is the highest 4-digit number? That is nothing but 9999. Divide that highest 4-digit number with this 270, that is LCM. So 270 into division 9999. Okay, so if you do it, you will get it around 18. You will get the remainder as 279. So after doing this division, you will get the remainder as 279. Now there is one simple rule, that is greatest number they are asking is equals to highest minus remainder. Okay, so if you are dividing that highest 4-digit number with 270, you are getting a remainder of 279. Now they are asking just simple understanding, simple logic. If that number is particularly divisible by this 270 LCM, there should be no remainder, right? So you have to take this remainder from this highest number. So simple formula you have to remember for these kind of questions. The greatest number is equals to highest number minus remainder. They are asking the greatest 4-digit number. So that is greatest 4-digit number is nothing but, what is that highest 4-digit number? 9999 minus this remainder 279. So that is nothing but 9720. That is your answer. Option B. So very small concept. The greatest 4-digit number exactly divisible by each of 12, 15, 18, 27. Right? For that, what you have to do? Take the LCM of all the given devices. You found out LCM is 270. They are asking a greatest 4-digit number. Now first take the highest 4-digit number. What is the highest 4-digit number? 9999. So divide it with that LCM, you will get one remainder. Now the simple formula is greatest is equals to highest minus remainder. So highest is 9999 minus remainder 279. So the answer is 9720. Now a similar question. Here they are asking the smallest. So the question reads, smallest 6-digit number that is exactly divisible by each of the 12, 15, 18 and 30. So what is the first step you have to do? Take the LCM. So how to find the LCM? 12, 15, 18 and 30. So you can use 3 4s are 3 5s are 3 6s are 3 10s are. And if you use 5 1s are 6s are 2s are. If you use 2 2s are 2 1s are 3 2s are 3 1s are. Right? 5 3s are 15, 15 2s are 30, 30 2s are 60, 63s are 180. So what is the LCM? 180. Right? Next you have to do is, what is the smallest 6-digit number? 1 and 5 zeros. Right? Now divide the smallest 6-digit number with this LCM. So 180, this 1 and 5 zeros. If you do this division, you will get 555. The remainder as 100. Okay. Take the LCM first. Write the least 6-digit number. What is the least 6-digit number? That is nothing but 1 and 5 zeros. Divide that least 6-digit number with this LCM. You are getting a remainder of this one. Now the small formula is smallest is equals to least plus divisor minus remainder. So there are two kinds of models, this greatest 4-digit number, smallest n-digit number. So for the greatest, a simple formula, highest minus r, highest minus remainder. For the smallest, what is the smallest number is equals to least plus divisor minus r. Here we are not just taking out the remainder, divisor minus remainder. So what is the divisor here? That is 180. 180 minus r. You have to add this to the least number. So 180 minus r is 80. So what is that least 6-digit number? 1 and 5 zeros plus d minus r, that is 80. So 10080. That is your answer. Option D. Understood? So these there are only two kinds of questions. They will either ask greatest n-digit number, which is divisible by all these by leaving some remainders and all. Next, the smallest n-digit number. For the greatest number, what you have to do? Highest minus remainder. Okay. For the smallest, least plus d minus r. Least plus divisor minus remainder. So smallest is equals to least plus d minus r. So 180 minus 180. So 150 80 is equals to the answer. Option D. Now using these two concepts, try to solve this one. Simple one. You have to apply either of the rules. The greatest 4-digit number which is divisible by 15, 25, 40, 75. Okay, let's solve this one. What is the first step you have to do? Take the LCM of all the divisors. So LCM of 15, 25, 40 and 75. So if you do it, 5 3s are, 5 5s are, 5 8s are, and 5 15s are. If you put 3, 3 1s are, 3 5, 8, 3 5s are. If you put 5, 1 1, 8 and 1, right? So 8 5s are 40, 43s are 120, 125s are 600. Now they are asking the greatest 4-digit number. First consider the highest 4-digit number. What is the highest 4-digit number? 9999. Divide it with this LCM 600. 616s are 9600. So 993. So this is your remainder. You got the remainder. Now what is the formula? Greatest is equals to highest minus remainder. What is the highest? 9999. Take out the remainder. So that is nothing but 9600. Understood? Option C is the answer. Solve the next one. The largest 4-digit number which when divided by 16, 24, 30, 36 leaves the same remainder 10 in each case. If you observe these kind of questions we have discussed in the LCM and HCF concept itself. But the small difference is they are asking the smallest or greatest 4-digit number, 5-digit number like that. Thus one component is only the difference. The rest of the concepts are same. Here there is one extra component, that is in the each case that is leaving the same remainder 10. In the earlier question that is perfectly divisible. Here they are adding one extra remainder in the each case. So try to solve it. Okay, how to solve this one? You know, the first step is to find the LCM. 16, 24, 30, 36. 16, 24, 30, 36. So if you put 4, 4 4s are, 4 6s are, sorry. So 16, 24, 30, 36. You can put 6, right? 16, 6 4s are, 6 5s are, 6 6s are. You can put 4, 4 4s are, 4 1, 5, 6. You can put 2, 2 2s are, 2 1s are, 2 5s are, 2 3s are. Right? 2 3s are 6, 6 5s are 30, 32s are 60, 64s are 240, 240 into 6. You are getting an LCM of 720. Try to find the LCM, that is 720. Next, what is the step? Largest 4-digit number they are asking. So now what is the highest 4-digit number? 9999. If you divide that with this LCM, you will get a remainder of 639. So that is your remainder. Now what is the next process we have done in the previous questions? Greatest number is equals to highest number minus remainder. What is this highest number? 9999 minus this remainder 639. This is nothing but 9360. Right? 9360. But this number is exactly divisible, right, by all these numbers, but they are asking it should leave the same remainder in the each case. When this number is exactly divisible by all the given numbers, and it should leave a remainder of 10 in the each case, so just add 10, right? Simple logic. 9370 is your answer. We have done similar questions in the LCM and HCF also. Only difference is they are asking n digit number, greatest n digit number, smallest n digit number. So what is the process? First you have to find the LCM. You can find the LCM. Some process is here, something wrong. The LCM is 720. Next, when they are asking the largest or greatest number, consider the highest 4-digit number, that is 9999. Divide it with the LCM, you will get some remainder. Next step is apply that formula. For the greatest number, highest minus remainder. For the smallest number, least plus d minus r, divisor minus remainder. So greatest number is highest minus r, that is 9360. What is 9360? That is the highest 4-digit number, greatest 4-digit number, that is exactly divisible by the given divisors. But here they are not asking exactly divisible. It should leave a remainder of 10 in the each case. So just add 10. So 9370 is your answer. Now this is the next model question. Here also same. The find the largest 4-digit number such that on dividing by 15, 18, 21, 24, they are leaving reminders of 11, 14, 17, 20 respectively. So if you consider how the questions are progressing, in the previous questions they are asking exactly divisible by the given divisors. The next model is they are leaving remainder same in the each case. Now in the each case the remainder is different. All these models we have done in the LCM and HCF. Apply the same concept here. with the two formulas, that is greatest is equals to highest minus r, smallest is equals to least plus d minus r. Try to solve this one. Okay, let's solve this one. So when there is case like they are leaving reminders in each case, I have already told you in the LCM and HCF, write down the divisor and remainder. So what are the divisors? 15, 18, 21, 24. What are the reminders in the each case? In the case of 15, 11, 14, 17, 20. Now consider d minus r. That means take out the remainder from the divisor. 15 minus 1 is 4, 18 minus 14 is 4, 21 minus 17 4. This is also 4. In every single problem in this model, you will get same difference. Then only these kind of problems can be considered. So in each case you are getting 4. Now keep that 4 separately. Now what is the first step? You have to find the LCM of the divisors, that is 15, 18, 21 and 24. If you find the LCM, you will get the LCM as 2520. Now what is the next step? They are asking the largest 4-digit number. Consider the highest 4-digit number, that is 9999. Divide it with this LCM. Find the remainder. You will get the remainder as 2439. This is your remainder. Now, what is the next step? When they are asking greatest, you have to apply the formula highest minus r. What is this highest? 9999 minus remainder 2439. That is nothing but 9 minus 2 7 560. Now you have put this 4 separately. Here you are getting that 7560. This 7560 is perfectly divisible by all these numbers. Now they are leaving the remainders 11, 14, 17, 20 each case. The difference, the same difference in each case is 4. Subtract this difference from here. That is your answer. 7556. Understood? We have already done these kind of problems. Consider the d minus r. In each case it will be the same. So keep it separate. Find the LCM 2520. Take the highest number. Consider the remainder. Formula for the greatest 4-digit number or the largest 4-digit number is highest minus remainder. Highest is 9999 minus this remainder. You are getting 7560. What is the meaning of this 7560? That is perfectly divisible by all the given divisors. Now subtract this difference from this 7560. That is your answer, 7556, option B. So this is how you should solve this question. Now at the end, this is for your homework. Question was asked in CSAT 2023 paper. Before coming to tomorrow's class, try to solve this one. So with this we are finishing the number system. All the 5 parts, number system, all the important concepts were covered. Next we will start with the concept of average. Thank you.